Now, using what we've just learned earlier, we can rewrite this and be a little bit clever. So instead of writing 8, we write this as log base 2 of 2 to the power of 3, because 2 to the power of 3 is 8. But remember, with this rule over here, if the exponent is not excluded, like there's no bracket over here, we can take the 3 down. So this is 3 times log base 2 of 2. And log base 2 of 2, we know from earlier, this is just 1. So this is the same thing as saying 3 times 1, which is 3. And that is your answer there. All right, we'll skip some of the calculator usage stuff over there, skip some of this here, and now let's go ahead and solve logarithmic equations. Okay, 2 to the power of x is equal to 8. Now, this is, if you wanted to, you can rewrite this as 2 to the power of x is equal to 2 to the power of 3. So x is equal to 3. 3 to the power of x is equal to 11. Now, over here, you cannot take 11 and 3 to make them the same base. So we write this as log. Log base 3 to the power of x is equal to 11. And in order to figure this out, we will need a calculator. So the nice part about this is we can use one of our rules earlier. Okay, I'll scroll back up to it here. It's, oh, wow, okay, here it is. If you ever want to figure out what log base b to the a is, you can just do log base x to the power of a is equal to log base x to the power of b. And it doesn't matter what log base it is. So, oops, I can make this as log base 10 to the power of 11 divided by log base 10 to the power of 3 is equal to x. The reason I like to do log base 10 is because if you click log on your calculator, it automatically assumes you have log base of 10. So in your calculator, all you have to press is log 10 divided by log 3. Okay. I personally like to put brackets around so that it doesn't get really mixed up. You don't have to. So let me type this in, log 10, oh, sorry, it should be log 11. Okay. Log 11. Log 11 divided by log 3, and that gives you 2.18. And that's x. So 2.18 is equal to x, because this is 2.18. And so I'm going to erase all this over here. You can review it and copy it down if you want. If you wanted to double check and say, oh, is the 2.18 actually the answer? You can just do 3 to the power of 2.18, and that gives you 11. All right, we're going to keep going. Log base 10 of x plus 3 plus log base 10 of x is equal to 1. Because we were adding them and they have the same base, this is the same thing as multiplying. So log base 10 of x squared plus 3x is equal to 1. We can put this over as, we can rewrite this as 10 to the power of 1 is equal to x squared plus 3x. Move it over, 0 is equal to x squared plus 3x minus 10. Right. And then if we do some simple factoring, 0 is equal to x plus 5, x minus 2. My two possible answers are x is equal to negative 5 and x is equal to positive 2. If you look and you plug both of these into here, one of them doesn't work. And if you realize that it's the negative 5, you're correct. Because if you plug it in, then we get log negative 5. And remember that this cannot be negative. Okay. The two restrictions are the bases have to be positive, and it can't be 1, and the number over here cannot be negative. So we reject this, and my only answer is x is equal to 2. I'm going to start doing these a little bit faster now. Because they're the same base, we can divide these since we are subtracting. So x plus 6 over x plus 2 is the big portion of the log. So log base 3 of this whole thing is the same thing as log base 3 of x. They have the exact same bases. So a couple of things we can do over here. I'm going to erase this just for space. Number 1, if you wanted to, you could take this to the power of this is equal to this. So 3 to the power of log base 3 of x is equal to x plus 6 over x plus 2. And one of the rules is saying that if you have the number to the log base of that same number, they cancel out. So you just get x is equal to this. But knowing that they have the exact same bases here, we can technically skip that part and just go right to this. All we have to do now is solve. So multiply both sides by x plus 2. X squared plus 2x is equal to x plus 6. Move everything to the left. X squared plus x minus 6 is equal to 0. X plus 3 and x minus 2 is equal to 0. Let me erase this over here so you get more space. X is either negative 3 or positive 2. And as you can already tell, we have to reject this because it fails this and this. Our only solution is x is equal to 2. Let's do a couple more over here. I'm going to make everything as log base 3 to the power of something. This is log base 3 to the power of x squared plus log base 3 to the power of x minus 1. Instead of writing 1, I'm just going to write log base 3 of 3 plus log base 3 of 2x. All right, combine everything together. Log base 3 of x cubed minus x squared, or multiplying since we are adding the same logs together, is equal to log base 3 of 6x. And since the two log bases are the exact same, just equate these to each other. Oops. So we have x cubed minus x squared is equal to 6x. Move everything to the left. X cubed minus x squared minus 6x is equal to 0. Factor out the x. X squared minus x minus 6 is equal to 0. X minus 3, x plus 2 is equal to 0. I'll give you some more space over here. All we have to do now is find the possible answers. X is equal to 0, x is equal to 3, and x is equal to negative 2. 0 fails because remember the inside has to be positive and it can't be negative, so this fails. 3 passes, but negative 2 also fails. So our only answer is here.